I did a little work with the Social Security names database, and I want to show you one of the pieces I'm most proud of and how I solved a really big problem in the very first step of my process. So I'm looking here at Social Security names, and when you download it, you come up with hundreds of files like this. They're actually text files. They're not CSVs. But you have the names of people. This looks like top is the girls, the name, how many people, the gender, and then how many people were born with that name. The year is in the document name. And if you go all the way down, you can start to see male 2. So this is a ginormous file. And hopefully you can start to see the difficulty of working with this. I wanted to make a database that has all of the different historical data points of these names, but they're in, you know, what 120 different folders, 140 different folders. And so I have to do something to merge them together and give myself a little more information so I can use my SQL queries and put it in Postgres and just kind of work with it a little easier. So that is when I wrote this. It is just like 20 lines of code, and I'm very proud of it. I'll walk you through it step by step. It's very simple. It's using pandas. So we start off, get the current working directory, nothing crazy. And then I'm going to make a list, a CSV files list, where I'm going to join the folder and the file name together to get like a reference. So I'm going to look back up those later. So I said, hey, pull all the ones that end in .txt. That's because this file is also in there. And so there is a .py file. So I wanted all the ones with .txt. So I have a big master list of every file in this folder, which has all of our years, 140 of them. And then I make a blank data frame. And then I do this for loop. This for loop goes through, it grabs the year, CSV file 37:-4. This is getting me the year mark. So it's 4 digits always, and starts at the 38th, 37th point, and then I want everything but the last 4, so those .txt. And so that's gonna get the year, and then I'm going to grab that, put it in a new data frame, and I've added my index columns, given it some names. The original ones do not have names. As you can see, it's just, there's no headers. And then I add a year, and then I try to combine them. I use a try and except, just in case I run into any sort of problem, to put them back together. And then from there, I get my combined data frame with all of my information across years. And it is not sorted. It's going to go through the order it did, but once again, everything I'm going to do in SQL later is going to be sorted. And then I can spit it out, data to CSV. And so I get a nice, clean, perfect CSV, the way I want it, the way I want it to get thrown into Postgres, and so I can start working on it. Let me see if there's any interesting SQL queries as a little bonus. And this was probably the most important thing I did. This is rank over partition by year and gender, order by total, descending as name rank. People love to use name ranks when it comes to baby names, and more so than they do numbers. The numbers are actually really interesting and different as the years go on, where the number 1 is not as more prevalent as the number 1 used to be. And so I have this name rank because sometimes I wanted to use the rank, you know, what was the first name of every year? What was the first name of this year? And so I created that one, and I used that, I made a temp table actually from that, so I can have that ranked names in there. So that is how I solved my problem with Python. I cleaned up data. I think most good data work is actually cleaning data work, because once it's clean, you can do your job really easily. It's like clearing off a road. It's sometimes better to have a dedicated snowplow instead of an ATV to go over everything. I don't know. Hope you liked it. Maybe you learned something, and if you want, you are more than welcome to steal this and use it for yourself.